Hello and welcome to today's overview and demonstration of the Denodo Professional Edition. The Denodo Professional Edition is a subscription-based offering that allows you to quickly launch a pre-configured Denodo data virtualization solution on AWS, Azure, or Google Cloud. The data virtualization solution will allow you to integrate and deliver data in real time with a flexible, consumption-based pricing model for small projects and departmental use cases, and will support up to 5 data sources. Development is done through a visual, no-code, low-code design studio that you'll see as part of the demonstration today. The Denodo Professional offering includes support, free onboarding courses, and a development license to ensure success, and enables a variety of integration use cases, including logical data warehousing, agile BI, and more. Denodo as a data virtualization layer provides an interface between disparate data sources and consuming clients, which include reporting tools, web services, analytical tools, and science tools like Python. It acts as an abstraction layer where Denodo simplifies all the complexities and variables of data, such as location, format, use methods, and protocols, all of which makes accessing and integrating data from multiple sources such a challenge. Denodo hides all this complexity. So for end users, their experience is as if they were pulling data from a single database view. This also means that end users can use their favorite reporting tools like Tableau, Power BI, or AWS QuickSights to access their data directly from the Denodo platform using either ODBC or JDBC drivers. A byproduct is that the users will get the same data in the same format no matter what reporting tool they use. And one more thing, every view or report can also be published as a web service, whether it's SOAP, REST, OData, or even GraphQL. In this demonstration scenario, we have a company that has recently run a marketing campaign, and the business wants to understand its impact on sales in various countries. It sounds straightforward, but there are some challenges based on the data sources. The historical sales data in this case comes from Snowflake. The marketing information comes from a JSON software as a service application, which is running in the cloud. And the customer detailed information is currently stored in an Amazon Redshift database. We need to federate and join all of this data together and then group and aggregate the data into a view and publish it as an API. Traditionally, this company has approached these types of data initiatives in two ways. The first way would be via a request to the IT department to build a small data mart with ETL jobs to extract, combine, and model the data from these disparate sources. The other way would be to have a power user who knows all of the data sources, manually pull the data, combine it, and put it into something like Excel to get started on the reporting and analysis. The first approach is costly and time-consuming for a single report, and the second option may result in mistakes and inconsistencies. So let's look at what we can do with Denodo. First, we create a connection in Denodo for each of these data sources. In the case of Snowflake and Redshift, we can create a JDBC connection and then have Denodo introspect the sources and create the relational views of the underlying tables. On the other hand, for the JSON-based campaign data, we can have Denodo make REST API calls and again create relational virtual tables. Since all these virtual tables are relational, I can easily create a view by combining the tables as if they were all coming from one database. I will then be able to create my report as an API over that view for consumption. Let's go to Denodo and see how we can create this view. The Denodo Design Studio is an easy-to-use web-based graphical user interface that is quite similar to a SQL or SQL database type tool, which indicates the types of skills needed to get started with Denodo. If you have a SQL or relational background, you will be able to pick up Denodo very easily. On the left-hand side, we have the virtual databases that I have access to. They are virtual since Denodo only stores metadata. In the data sources layer, we have access to all the data sources that I've been granted access to. Let's go and take a look at the connection configuration for the Redshift data source. The adapter tells Denodo about the underlying data source and allows it to generate the most optimal query for that data source. By knowing the capabilities of the underlying source, Denodo can take advantage of its performance engine. For example, it will rewrite the query to optimize the performance against Redshift. As you can see, there are adapters for different types of data sources, from relational to cloud, to data lakes, to multidimensional structures. Here is where you would specify the connection URI and define the authentication method, such as using a simple login and password. But as you can see, we could also use Kerberos AWS IAM credentials, or we can even store credentials in one of the password vaults that several vendors are currently offering. Now from this source, we can create a base view of the tables we need for a report. Base views are a logical representation of the physical tables from our data sources. Here is the base view for the customers that I created from Redshift. Now when I run this particular view in Denodo, it is going to make a real-time connection to the Redshift database and return the results from this table as they exist in real time. Now let's take a look at another type of data source, in this case a non-relational one. Here is a web service from a cloud application that returns marketing information. In the configuration, we can see that it is using a HTTP method to retrieve the data. There is a URL, and we can also see several other configuration options like authentication. Here is a view that we have created on top of this data source. We use this base view by connecting to the source, calling the web service, pulling the metadata and parsing it so that it looks like a relational table. Because it is now in relational format, I can run SQL or SQL queries against it. When we execute this query, the JSON array structure will be flattened to be two-dimensional and normalized into a relational format so that it can be easily joined with other data. This is the same for CSV files or semi-structured data in Denodo. They will look like relational tables so that we can very easily join data from different sources and create different views for the business. Let's now take a look at the logical model we have created for this scenario, campaign management evolution. In this logical view, we can see that it is sourcing data from the campaign management JSON document. It is sourcing data from the Snowflake Cloud Data Warehouse for sales transactions, along with the date dimension. And the customer information is also sourced, and that's coming from Redshift. Now, if I go ahead and run this query, it will be pulling data from a fact table in Snowflake with about 20 million rows, a customer dimension with about 100,000 rows in Redshift, and our JSON document, which is coming from a web API. So how will this go from a performance perspective? How is Denodo able to federate 20 million records across 3 different data sources in such a short amount of time? The Denodo optimizer delegates as much processing as possible to the underlying data sources. This makes sense in this case as technologies like Snowflake and Redshift have powerful processing engines that can be leveraged to process millions and millions of rows of data. A main hindrance to performance is often the movement of lots of data across the network. Denodo will always try to minimize this by leveraging different optimization techniques. In this case, 2 optimization techniques were used. The first technique that we see is data movement. In this case, Denodo's optimizer has determined that it's faster to query the customer table in Redshift and copy that data over to Snowflake, where the larger table resides. Denodo does this so we can take advantage of the second optimization technique, aggregation pushdown. Denodo pushes down all of the group by aggregations to the source, in this case to Snowflake, whenever possible. This type of execution is unique to Denodo, and when it is used, only the aggregated data is pulled over the network. So for an example, instead of 20 million rows of data flowing over the network, we get these 150 records because Denodo has aggregated by the countries that we do business in. Now that we've created our view, the next step is to make this model available to end users. Let's first publish this view as a web service. By selecting the view, I can then create a new REST web service and then save and deploy that service with the right credentials. Anybody who has access to this URI can access this web service and access the view that we've created. As you can see, we can also publish the OpenAPI in different ways, supporting JSON and YAML specifications. By clicking on the link, Denodo will run the same query and return a result set in HTML format through that web service API. Next, let's look at how a BI tool would consume this data. Here I have Microsoft Power BI open, and as you can see, I'm connected to the same view, Campaign Management Evolution. And on the left, you will see the result set. For BI tools like Power BI or Tableau, and there are others, Denodo is just a relational database that you connect to via different methods like ODBC or JDBC. The BI tool sends the query to Denodo, which will perform things like federation and optimization. This way, the reporting tool can do what it does best, creating great visualizations, while Denodo handles the complexities of sourcing the required data. So that concludes the demonstration, but let's look further on security and the benefits of Denodo. Denodo provides a centralized security model across multiple consuming applications and across multiple data sources. This means that different reporting tools and web services will have the same access to the views, which simplifies management and ensures the data is always delivered consistently. Denodo can provide data-specific permissions all the way down to cell level. By leveraging role-based security, you can apply column and row level restrictions, and this includes masking and redaction of fields depending on the user's roles and level of access required. And finally, I would like to leave you with 5 key benefits of data virtualization. Data virtualization provides a single point of access for all of your data assets. The Denodo data virtualization layer will act as a single virtual repository for your enterprise. It minimizes data replication. It minimizes data movement. Denodo delivers data on demand from source systems to data consumers without any additional steps. It provides centralized security, metadata, and governance. It is a single consolidated access point for your business, for self-service data services, and it is data and tool agnostic. If you would like to try a free 30-day trial of Denodo Professional on AWS, Azure, or Google Cloud, please go to www.denodo.com/free-trials. And thank you for watching.